hope by now that you're beginning to be convinced of the importance of statistics as the backbone to data science and machine learning. And so when we think of statistics, we think of two main types of statistics: the descriptive statistics and the inferential statistics. And similarly, when we are building our machine learning model, an essential part of that is first getting an understanding of the data understanding, data profiling, or as we sometimes refer to it as the exploratory data analysis. And that is all about descriptive statistics. This is the simple yet powerful tool that helps us to understand and to summarize and to make sense of our data. Without proper descriptive statistics, a proper understanding of our data, we will not be able to build sound, rigorous, scalable, reliable machine learning models. And so we have to make sure that we can build models or make predictions that are based on a thorough understanding of our data. And that's where descriptive statistics comes in. It reveals a data set's essential characteristics. What's there and how much of it, what is typical, what is extreme, what is the spread of the values, what type of data do we have in terms of the random variables. And this initial exploration is our first crucial step in transforming raw data into meaningful insight. So let's talk about these essential steps in any practical machine learning project. The data exploration begins with the investigation of the data. And it starts with univariate analysis, which means analyzing your data one variable at a time. You're asking, what is the personality of the single column or single feature in the data set? And so we have an example here. This is measuring, it records heights of 7 students in centimeters, and you're looking at just one variable, height. The goal is to be able to describe this feature's shape, its center, as well as its spread. And for that we use simple charts because we can represent them numerically, of course, but the visuals mean so much more. Really, a picture is worth 1,000 words. And so when we think about representing the distribution of our data, there are some simple charts that we always include. And so for numerical data that is continuous, so for the continuous random variables, we use histograms. So for age and income and temperature, we use income. This is a quick way to tell if the data is normally distributed, if it's symmetric, or if it's skewed. And then for the categorical data, we would use a bar chart. So male and female in this case, or if we have different groups, different countries represented, or different states, we would use a bar chart. They show a simple count of each of the categories. We also use bar charts. We also use pie charts. Some people like to discredit the bar chart, discredit the pie chart, but the pie chart can be very effective, very informative in showing us the proportion or the percentage of each category represented by the slice. And this shows us how each category is relative to the total. So for example, the sales percentages for each year is represented here, and so we can see that there is relatively a uniform type of distribution for each year, with 2012 having a slightly, 2013 having the highest measure, but all of the others are around close to that value. Now, in addition to the univariate analysis, right? So that is where we're looking at just one variable, one column, one feature at a time. We would also want to perform our multivariate analysis. This is where we begin to discover the relationships between the features. So the multivariate analysis can represent different aspects related to the observation. So if a manager wants to compare the popularity of 4 advertisements on a website, the relationship between the variables here is examined. So we have the gender, we have the click rate, and we have the department. And we can see that there is a definite relationship here where click rates for the male is really high in ad 1, but it's highest for females with ad 2. So there is something going on as far as the relationships between the gender and the click rate and the different ads are concerned. And one of the best ways to visualize the relationship between several different variables at the same time is to use a heat map. So it allows you to visualize the correlation. The color is representing the strength, the intensity of the correlation between the variables, and you can see all of the pairs of relationship in one visual. A bright color means that it's a strong positive link. So 1 is represented by this lightest color here. So of course everyone is strongly correlated with itself. So you look outside of the diagonal. So here we see length of service is strongly correlated with age. And we see that's the strongest of the positive correlation. There is also strong negative correlation, where the employee ID is strongly negatively correlated with the length of service and the age. And so what it's saying is, as the employee ID value goes up, the length, I should say that the other way. So the length of those with a longer length of service would have a lower ID. I guess they start off giving everybody lower numbers, and as the employee numbers increase, the employee ID gets longer. Similarly, with the age, the older employees tend to have a shorter or smaller or lower employee ID. So that's the correlation. The univariate describes the players, the multivariate describes the teamwork, but both are mandatory steps for cleaning and preparing your data before you can build a high precision machine learning model. Now, there are some things you want to be aware of when it comes to the multivariate analysis. This method, the method you choose depends on the goal. So there are common techniques like the regression analysis, regression So there are common techniques when it comes to multivariate analysis. There's regression analysis, or principal component analysis, or path analysis, or factor analysis. These are all methods that you can use to investigate the relationship between the variables. The specific goals determine the type of technique that you use. So you might want to predict one variable based on another, or to identify the underlying factors that explain the patterns, or to compare the means across to the different multiple variables. So you would use the ANOVA or the MANOVA. In multivariate analysis, the interpretation of the multivariate analysis is what reveals the complexity of the relationship within the data, the patterns that aren't visible when you examine just a list or a table.